guys, welcome to this YouTube channel Easy Engineering. How are you? Hope you all are doing good. And see, in the last class we have discussed about function pointers. I hope you all understood about function pointers clearly, and if you have any doubts you can comment me down, okay? I'll see each and every comment and reply to those comments, and I'll clarify your doubts. And the next topic we are going to discuss is dynamic memory allocation. Okay, dynamic memory allocation. First, what is dynamic memory allocation? Means, see, it provides the flexibility to allocate memory during runtime. See, when we are compiling a code, see, first we are going to compile it and then run it to get the output. Compiling because if there are any errors in the code which we have written, then in the compilation you will be getting the list of errors. Okay, if there are no errors, then run will be comes into place, and then the running of program will be takes place. Okay, so while compiling while executing line by line, if we have declared like int a equals to 5, then a will be stored in the memory. Means some int takes how many bytes of memory? It takes 2 bytes of memory. So that 2 bytes of memory will be allocated to a in the memory. Okay, in the compiler, in the compiler 2 bytes of memory will be allocated to the variable a. So actually the allocation of memory will be done at compile time only, but here in dynamic memory allocation the memory will be allocated dynamically, because see, in this case we are going to allocate the memory during runtime. See, here you have runtime, right? During runtime means while compile time there is no memory allocated, but during runtime when the program is running line by line, means it is printing the output, then at the time the memory will be allocated. Okay, means, see, while compiling we don't know, means we don't know exact amount to be allocated. So dynamic memory allocation comes into place. See, then at that time the memory should be allocated at runtime. While running the program, we'll be knowing the exact number of exact amount of memory to be allocated, right? So that memory will be allocated at the runtime, during runtime. Okay, so benefits. See, from this we are going to know the benefits of dynamic memory allocation. What it does, like, see, memory won't be wasted, right? Memory won't be wasted. Like, see, at the time of arrays we have discussed that in arrays, see, we have to give some maximum amount of memory allocation during compile time, right? So for example, if we don't know the exact number, we are just giving some random number, like that is also a bigger number, like 50 or 100, but an array won't consist of 50 numbers. See, right, we can't assign 50 numbers, right, in an array. It is manually, it is not possible at all. So that is the reason. So we are going to use dynamic memory allocation. So while this dynamic memory allocation, we are going to give the allocation at the runtime only. So I hope you have understood about the definition. And next, see, in C The memory management is done using the library functions such as malloc, calloc, realloc and free. See, in C programming language, we are the memory management can be done, means the memory can be allocated and deallocated based on, not based on, using library functions. See, I have said about library functions, right? At which topic? At the types of functions we are having library functions also. Okay, at that time I have said that library functions are predefined functions, means those are already defined and stored in the compiler, which are used when if you give the name of that function, then the code will be executed as it is, because it is already allocated, means it is already allocated inside the compiler. So when we give that a small like function name, then that code will be comes into place and it will be executed. Okay, so what are those library functions? Those are malloc, calloc, realloc and free. We are having four library functions which are used in dynamic memory allocation. Okay, then we are going to discuss about those, okay, those four in detail. See, the first one is malloc. Okay, means M stands for memory, and alloc is a short form of allocation, means memory allocation, means we are allocating memory, we are storing some, means we are just assigning some memory to something like that. Okay, then it allocates a specified number of bytes of memory and returns a pointer to the beginning of the allocated block. Okay, let me describe it, this sentence. See, it allocates a specified number of bytes of memory, means it allocates some specified number, means we have to specify it, the user have to give how many number of bytes of memory should be stored. Okay, and it returns a pointer to the beginning of the allocated block, means it gives the pointer, means the starting address. Pointer means the address, right? Pointer to the beginning of the allocated block. Some block means like an array, it will be allocated, right? Serial manner. Okay, so the first one, let me draw here. Yes, this is the memory allocated, right? See, here you will be having this. Yes, let's assume we are going to allocate 4 bytes of memory, and it returns this address. Okay, this address will be returned after allocating. Okay, yes, means see, while allocating this, then the user can identify from where the block starts and how, and he can describe it. Okay, he can use it whenever it is needed. So after that, we are having the memory is uninitialized, so it contains garbage values. See, memory cannot be uninitialized, right? Means we cannot initialize memory, means see, the compiler will be having a huge bytes of memory. See, some like 256 GB, means gigabytes. Giga will be some 10 to the power of something bytes. Okay, so that cannot be initialized because that's a vast storage. So if we try to give something, some value, means see, we are going to run once, then it gives some other value, then again if we run, it will be going to give us another value, because see, the garbage values will be collected. Okay, so those values will be displayed for us. So this is the example. Actually it is not an example, it is just syntax, means how to write the program. Okay, it can be like example also. I'll just try to execute it clearly. Okay, then let me copy it and let me, yes, paste here. Yes, now I'm going to just edit something, void main. Yes, oh, something is happening. Okay, yes, now I have to, yes, here we have to write the what we have to write. See, no, first I'll write and I'll say that I'll explain it. Memory, yes, okay, let's try what happens. Let's run and see. First, will it execute it or not? No. Okay, something happened here. Yes, after void main we haven't given this close braces. Yes, see, we have to, okay, we are not getting any output, right? So to get output sorry, here we are adding else block, printf, oh, yeah, allocate it for you. Yes, yes, let's see now what will be the output we are getting. Yes, we are getting Yahoo memory is allocated for you. Yes, see, let me explain it. See, for using this standard library functions, we have to use this line also. This line will be extra. See, in string manipulation functions we have used like hash include, let me again write here, hash include string.h, right? We have used this. Okay, for this memory allocation functions we have to use this line. This line should be mandatory with stdio.h. okay, so after writing those two, usually we are going to void main, right? In void main, see, we are declaring a pointer variable, because see, in definition we have seen that in definition, see, okay, it allocates a specified number of bytes of memory and returns a pointer, right? It returns a pointer. So here to return that pointer we should have something, right? So this is initialized, means this is declared, this variable is declared and it will be equalized to, see, int will be the what, the data type. Okay, int star, this star should be inside and it is the syntax, you have to remember as it is. And malloc, it is a keyword. Okay, it is not keyword, actually it is a function, right? It is a function which is a standard library function which is inbuilt in the compiler. Okay, so malloc, here our function starts. Okay, this is the function up to here, up to this brace, up to this, yes, this is our function. Okay, this from malloc to here, this is our function. Okay, this total, this is our function. Okay, now inside the function we have to give some attribute, some parameter, right? So in that parameter you have to give 10. 10 means, see, we are going to allocate 10 variables, means 10, okay, 10 allocations, right? So you have to allocate 10. Let me explain here. Let me take another color. Yeah, no, yes, let me take this. Let me increase the thickness and okay. See, to allocate 10 variables. Yeah, I'm in that particular program, I'm going to allocate 10 variables. Okay, to allocate 10 variables in a serial manner, you have to what here you are declaring. Let me draw first. 7, 8, 9, 10. Okay, see first here we are allocating 10, means we want to have 10 spaces allocated in the memory. So these are 10, right? In array format, means in dynamic memory allocation it will be done in array format only. So okay, while allocating this, see 10, these are 10, and into we are having into, okay, into size of int. size of int I can't write total, okay. Size of int, because see 10 variables but one space requires one is int, right? This the data type of these is int, right? So int uses 2 bytes of memory. So 10 into like that 2, each see each variable allocates 2 bytes of memory. So 10 into 2, total 20 bytes of memory will be allocated. So that is the main reason to write that syntax, right? That is the main reason to write that syntax. Here we are having same, that only malloc, means we have to memory allocation of 10 variables into size of int. If this pointer is float, then here also you have to write float, and here also you have to write float. Okay, let me see whether it will be executed or not. Let's see. Yes, this is also executed, because see what means we are going to store float, means float data typed values will be stored. Okay, so that is the meaning. And here see whether we if we want to know that the memory is allocated or not, then we have to use these statements. Okay, see if ptr equals to null, means see if it is allocated some like, see let me some address will be given to this, right? ptr, if the memory is allocated, some address in a hexadecimal format will be given to that. But if memory is not allocated, then there is no memory, means no address is given to ptr, right? So if no memory is given to ptr, then it returns null. Okay, so let me see, printf, okay, %x, yes, star, not star, normal ptr. Let me see whether it will be executed or not. Run. Okay, yes, something is happened. Let me see what happened. Okay, here the access specifier of pointer will be %p. Actually I have forgotten it. And now if we run, yes, we are printing something, right? Yes, here let me run again. See, now the value of pointer is this, right? So if the this are not allocated, means the storage is not allocated memory, then the PTR will be null itself. Okay, then this will be executed if PTR is null. Else means here PTR is not null, right? It have something, some XYZ something value. Then else part will be executed. Yahoo memory is allocated for you. Okay. So this is the end of today's lecture. See, it's almost 21 minutes. So in the next class we are going to discuss about, see, we are having still 3, right? Okay, still 3. C-alloc, re-alloc and free. These will be explained in the next class, and until then do watch my videos and start learning. And if you like the content, do subscribe to my channel, and if you like this video, you can like it. You can like the video and share it with your friends to whom it will be helped. Okay, thank you. That's all for today. If you have any doubts, comment me down.